Hello everyone. On this video we will be looking at the rational zero test and fundamental theorem of algebra. Okay, so let's say if the polynomial, let's say f of x equals a sub n, x to the power of n plus a sub n minus 1, x to the power n minus 1 plus, and it keeps on going all the way until you get to your x term and your constant coefficient. Okay, so if these coefficients are integers, then every rational zero of f of x has the form, or the possible rational zero, is equal to the factors of your constant coefficient, which is a sub 0, divided by the factors of your leading coefficient, which is a sub n. Okay, where the numerator and denominator have no common factors. Okay, so in other words, the numerator and denominator, you can't factor out a common term or a common constant and simplify it. So the numerator and denominator, the entire quotient, is in its simplest form. All right. Now, one way to remember this, you have a sub 0 over a sub n, is to remember the word on. A sub 0 is on top, a sub n is on the bottom. All right. So if you are still writing this, feel free to press pause, but we're going to go ahead and jump right to our first example. Okay, so what if we wanted to find the rational zeros of x to the fourth power minus x to the third plus x squared minus 3x minus 6? Okay, so first thing we're going to do is try and figure out our possible rational zeros. So we know we have 1x to the fourth minus x to the third plus x squared minus 3x minus 6. Okay, now in this case, our a sub n is equal to 1, and our a sub 0 is equal to negative 6. Okay, so our possible rational zeros, remember it's factors of a sub 0 over factors of a sub n. Okay, now what's a factor of a sub 0? Well, what number can you divide into it, and your answer will be a whole number? Well, you can divide positive or negative 1. You can divide it by positive or negative 2. You can divide it by positive or negative 3, and you can divide it by positive or negative 6. Okay, what about 1? Well, you can divide it by positive or negative 1. Okay, so every combination here is going to equal either positive or negative 1 as our option, positive or negative 2, positive or negative 3, and positive or negative 4. Because you have 1 over 1, 2 over 1, 3 over 1. I mean, not 4, 6. Sorry about that. Positive or negative 6. Okay. So these are all of your possible rational zeros. And we're going to use synthetic division to test each, at least until we come up with our answers. Okay, so first thing we're going to do, we're going to try k equals negative 1. Okay, so we have negative 1. Then we're going to use all of our coefficients. So you have 1, negative 1, 1, negative 3, and negative 6. 1, negative 1, 1, negative 3, and negative 6. Okay, so we bring down our first one. Oh, let me move this up a little. Okay, Negative 1 times 1 is negative 1. We add these together. Negative 1 minus 1, well, plus negative 1 is negative 2. Negative 1 times negative 2 is positive 2. We add these together. 1 plus 2 is 3. Negative 1 times 3 is negative 3. We add these two together, so we get negative 6. Negative 1 times negative 6 is positive 6. We add these two together, and we get 0. So our remainder is equal to 0. So when that's the case, we know that x minus negative 1 is a factor of our f of x. Okay, and our f of x is just this up here. Okay, so remember how we rewrite it, because remember this is our 1x to the fourth minus x to the third plus x squared minus 3x minus 6. Our exponent drops 1. So this now becomes 1x to the third, because this is the 1 here, minus 2x squared plus 3x minus 6. Okay, so that means, let me show you exactly where we're going to start off. Because this is a fourth degree polynomial, let me kind of put this up here. Fourth degree polynomial, we're going to start off with f of x equals x minus something times x minus something times x minus something times x minus something. Okay, because in order for us to find out the zeros, we have to factor this and then set each factor to 0. Okay, so that means that our f of x is going to equal x minus something times x minus something times x minus something times x minus something, but we already know one of the factors here. Okay, so that's going to equal x minus negative 1. Okay, so that's one of the factors. These three, we don't know yet, but we do know that this is what's left when we factor it out. So these three, now we know it's x to the third minus 2x squared plus 3x minus 6. Okay, so now we just have to factor this to match these three. Okay, so this will just be f of x, well, not f of x, we already have that there, x plus 1. Let me move this up a little bit, times this, x to the third minus 2x squared plus 3x, let me clean up that 3, plus 3x minus 6. Okay, so now we use synthetic division to factor this. You could, if you wanted to, you could use factor by grouping to solve it right here. But we're going to go ahead and do a couple more of these synthetic division steps to make sure you got it. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and continue this on the next page. Okay, so where we left off, we had f of x is equal to x to the third minus 2x squared plus 3x minus 6 times x plus 1. Okay, so we're going to go ahead and factor this using synthetic division. Now we did k equals negative 1. Now we're going to try k equals 1. Okay, now just going back to the previous page for a second. Remember, we're going through each one of these. You don't have to go in any specific order. If you want to try 3 and 2, then negative 6, you can go in any order you like. We're just going over all of our possibilities. Okay, so we go try k equals negative 1, or k equals positive 1 in this case. So we have 1. So now we don't use the coefficients from before. We use these coefficients. Okay, so you have 1, -2, 3, and -6. Okay, so we go ahead and bring down the 1. 1 times 1 is 1. Add those together. So we end up with -1. 1 times -1 is -1. Add those together. We end up with 2. 1 times 2 is 3. Add those together. We end up with -3, which is all fine and dandy, but the remainder does not equal 0. So we know that 1 is not a 0 of f of x. Okay, so r does not equal 0. So 1 is not a 0 of f of x. Okay, so that means now we're going to try a different one. So we know k equals 1 didn't work. What if we try k equals 2? Now, because this wasn't a 0, we're going to keep the same coefficients because this one didn't work. We only change the coefficients if we end up with r equals 0. But because this didn't work for k equals 1, we keep the same coefficients. Okay, because we have 1, -2, 3, -6. All right, so again, we bring down the 1. 2 times 1 is 2. You add those together. We get 0. 2 times 0 is 0. We add those together, we get 3. 2 times 3 is 6. We add those together, and we get 0. Okay, so we know that 2 is a 0 of this particular f of x. Okay, so that means, remember, we had f of x equals x minus something times x minus something times x minus something times x plus 1, because we figured out that -1 is a 0. Because you plug in -1, you get 0, which makes everything a 0. All right, now we just figured out that x equals 2 is a 0. Okay, now remember, once we find our 0, this started out as x to the third minus 2x squared plus 3x minus 6. Remember, your exponents drop down 1. So this becomes x squared minus 0x, or plus 0x, doesn't matter because it's a 0, plus 3. All right. So that means that this x plus 1, we already figured that out. And these three, we know that one of those factors is 2. So you have x minus 2, because if you plug in 2, you get 0. And these two, to figure this out, is x squared plus 3. Okay, so we have them, we're getting them one by one. Okay, now once you get it down to x squared, you can go ahead and use any method you like. Okay, so you have x squared plus 3 equals 0. Subtract 3 from both sides, you get x squared equals -3. We square root both sides, we get x is equal to plus or minus the square root of -3. Okay. Now if you remember, since the square root of -1 is equal to I squared, or I rather, not I squared, you have x is equal to positive or negative square root of 3 I. All right. So that means, I'm going to drop this down a little bit, f of x is equal to x plus square root of 3i, x minus square root of 3i, x minus 2, and x plus 1. Okay, so that means the zeros are any values that would make this equal 0. So you have negative square root of 3i, or x equals, equals negative square root of 3i, positive square root of 3i, 2, and negative 1. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page. Okay, so what are the actual rational zeros of f of x equals x to the third plus 3x squared minus 25x plus 21? Okay, so using the possible rational zeros formula and synthetic division, I want you to press pause and try to do this one on your own. Alright, so I'm assuming you've pressed pause and you worked this one out. So let's go ahead and verify your answer. Okay. So remember, your possible rational zeros are your factors of a sub 0 divided by your factors of a sub n. Okay, so we know here a sub n is equal to 1 and a sub 0 is equal to 21. Okay, so your possible factors of a sub 0, well, you have positive or negative 1, you have positive or negative 3, you have positive or negative 7, and positive or negative 21. All those numbers, if you divide 21 by any of those numbers, you'll get a whole number. Okay, so possible factors of 1 is just positive or negative 1. Okay, so because your denominator is either positive or negative 1, your possible zeros is going to equal positive or negative 1, positive or negative 3, positive or negative 7, or positive or negative 21. Okay, so what if we start with k equals 1? It's pretty simple. Okay, so we know just the fact that this is a third degree polynomial, we know our f of x is going to equal x minus something times x minus something times x minus something. Okay, so if we start with k equals 1 and use our synthetic division, you have your coefficients, just 1, 3, negative 25, and 21. 1, 3, negative 25, and 21. So we bring down our first one. 1 times 1 is 1. Add those together, you get 4. 1 times 4 is 5. Add those together. Oh, 1 times 4 is 4. I'm thinking 25. There we go. Add those together, you get negative 21. 1 times negative 21 is negative 21. Add those together. All right. Lucky enough, we get our remainder equals 0. Okay, so we got lucky on the first one. Okay, so remember that this top row of coefficients is your x to the third plus 3x squared minus 25x plus 21. So this row here, that exponent is going to drop 1. So instead of x to the third, this is going to be 1x squared, or just x squared plus 4x minus 21. Okay, so we know that 1 is a rational 0. So that means we go to f of x is equal x minus something times x minus something x minus 1. Because if we plug in 1, we'll get 0. Okay, so we know these two can be factored to that one. So you get x squared plus 4x minus 21 times x minus 1. Okay. Now the thing is, we can do synthetic division again for this one, or you can just factor it. You only have to do synthetic division enough times to where you can factor it on your own. Okay, so this, we know that this is x plus 7 times x minus 3. Okay, so that means our f of x is equal to x plus 7 times x minus 3 times x minus 1. Now we can find our zeros. We just said x plus 7 equals 0, x minus 3 equals 0, and x minus 1 equals 0. Subtract 7 from both sides. Oh, move this up a little. X equals negative 7. Add 3 to both sides. X equals 3. Add 1 to both sides. X equals 1. Okay, so your rational zeros are x equals negative 7, 1, and 3. Now you don't have to put them in ascending order. I just happen to do it. Any order is fine as long as you have all the values there. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next page. The fundamental theorem of algebra. Okay, so it states that if your function f of x is a polynomial of degree n, where n is positive, is greater than 0, then f of x has at least one 0 in the complex number system. Okay, now remember, that means a real number can be written as a complex number. Let me give you a few examples. So for example, 2, well, complex number first is a plus bi. So 2, of course, being a real number, you can write that as 2 plus 0i. Okay. So if we were going just by the fundamental theorem, if you have f of x equals x minus 2, we know that's a 1-degree polynomial. So we know that has 1, 0. And that's x equals 2. Because if you plug in 2, you have f of x equals 0. What about if you have f of x equals x squared minus 6x plus 9? Has 2 zeros. Because x squared minus 6x plus 9 is just x minus 3 times x minus 3. So your 2 zeros are x equals 3 and x equals 3. Okay. It didn't say they had to be different zeros. Sometimes the zeros are repeating, and this is the case. Okay. So what if you had f of x equals x to the third plus 4x? Okay, this is a third degree polynomial. But if we factor an x out of both, that's equals x times x squared plus 4. Okay, so to make this equal 0, we can either make x equals 0 or x squared plus 4 equals 0. All right, so if we make this equal 0, if we subtract 4 from both sides, that gives us x squared equals negative 4. We square root both sides, that gives us x equals plus or minus square root of 4i, because negative 4, the square root of a negative 1, is equal to I. Okay, and square root of 4 is 2, so that means our x is equal to plus or minus 2i. Okay, so in this case, our zeros are at x equals 0, negative 2i, and 2i. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page. Which is just a little friendly hint that if a plus bi is the zero of a function, which is your complex value, then so is the complex conjugate. Okay, so for example, what if you know that 3i is a rational zero? Then so is its complex conjugate negative 3i, because 3i is just 0 plus 3i, and its complex conjugate is 0 minus 3i. Okay, so what if 2 minus 7i is a rational zero? Well, not rational, let's say it's a zero. Then so is 2 plus 7i. Okay, so if you're given the fact that 1 is a zero, then you know the complex conjugate of it is also a zero. If this is a zero, then so is its complex conjugate. All right. So if you are still writing this, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so what if we wanted to find the function that has an output of 16 when x is equal to 2 and has zeros 1 and 2i? Okay. Oh, sorry about that. I thought it was in the middle of the screen. All right. So one thing we can see here is that 2i is a zero. Since 2i is a zero, so is negative 2i. I'm going to get it started for you. I want you to finish up, but I'm going to kind of get it started for you. Okay, so we know 2i, negative 2i, and 1 are zeros. So what I want you to do is go ahead and press pause and finish the rest of this answer. Remember, I kind of got it started for you. So I want you to finish the rest of it. Alright, so I'm assuming you have already pressed pause and finished up. So let's go ahead and verify your answer. Again, these are your zeros here. We have 1, negative 2i, and 2i. So we know that f of x is going to equal a times x minus something times x minus something times x minus something, and it keeps on going. But the fact that we know we have 3 zeros, 1, negative 2i, and 2i, lets us know that we only have to go f of x equals a times x minus 2i, x plus 2i, and x minus 1, because they already gave us our zeros. So we know this is a third degree polynomial. Alright, so if you want, you can factor those two. I mean, not factor, but FOIL those two. So we have f of x equals a, so we do the first, which is x squared, times our outer, which is plus 2i x, and our inner, minus 2i times x, and our last, which is minus 4i squared, times x minus 1. Okay. Now remember, for your complex numbers, I squared equals negative 1. So this will become negative 4 times negative 1. And of course, these two cancel each other out. So this will become positive 4. So we have f of x is equal to a times x squared plus 4 times x minus 1. So we go ahead and we FOIL this. Okay, so that gives us f of x equals a. We have x squared times x, which is x to the third. We have our outer, x squared times negative 1, so I have negative x squared plus 4x minus 4. Okay, so this helps us out quite a bit, just knowing where our zeros are, because we were able to come up with our function. But we're still missing one. We're still missing that a value. Okay, so how do we find that a value? Well, they told us an output of 16 when x is equal to 2. Of 16 when x is equal to 2. That's just a fancy way of saying that f of 2 equals 16. Okay, so we get this, and we use the fact that we know this to solve for our a. Okay, so we know that a times x to the third minus x squared plus 4x minus 4 is our f of x. So we know that f of 2 is equal to a times 2 to the third minus 2 squared plus 4 times 2 minus 4, and we know that's going to equal 16. Okay, so all we have to worry about is this part here. So we solve that. Okay, so 2 to the third power is 8. So that's a times 8 minus 2 squared, which is 4, plus 8 minus 4 is equal to 16. Okay, so this is 16 minus 8, which is 8. So we know that a times 8 is equal to 16. Divide both sides by 8. We have a is equal to 2. So we get this 2 and plug it into our f of x formula. So that shows us that f of x is equal to 2 times x to the third minus x squared plus 4x minus 4, or you can distribute it to each one if you like and make it 2x to the third minus 2x squared plus 8x minus 8. Either one of those would be correct, so you'll be right either way. Just depends on the form you want to leave it in. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. I want to make sure you get it. Okay, oh, thought I wrote this down, but I guess I did not. What if we wanted to find all the zeros of f of x is equal to x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. Given that 1 plus 3i is a zero of f of x. All right, so what I want you to do is I want you to, one, notice that this is a fourth degree polynomial. Okay. And notice that this is a zero, so its complex conjugate is also a zero. All right, so what I want you to do is go ahead and press pause and try to solve this one on your own. All right, so I'm assuming you've pressed pause and worked this one out. So let's go ahead and verify your answer. Okay, so we know that if 1 plus 3i is a zero, then so is 1 minus 3i. Okay, so we're part of the way there. It's a fourth degree polynomial, so we have two of our zeros already. Okay, so fourth degree polynomial. Okay, so when you have your fourth degree polynomial, you already kind of know how it's going to look. You have your f of x is equal, forgot my a there, x minus something, x minus something, x minus something, x minus something. All right, so that means if we know two of our zeros already, then that means that your f of x is going to equal a times x minus something, x minus something, x minus 1 plus 3i, and x minus 1 minus 3i. Okay, because if you plug in 1 minus 3i, so 1 minus 3i minus 1 minus 3i is 0. 1 plus 3i minus 1 plus 3i is 0. So we have two of them out the way. Okay, so how do we find the other two? Well, first thing you do, you get these and you FOIL them out. Okay, so let me I'm going to get this one and do this kind of down here. So if you have x minus 1 plus 3i times x minus 1 minus 3i, probably the simple way to do it would be to distribute the negatives in here. Okay, so that gives us x minus 1. Well, actually, that might be a little more work, so I'll hold off on doing it that way. I'll just go ahead and FOIL it like this. I'm trying to think of the easiest way to do it for you. Okay, so if we go ahead and FOIL it like this, we have x squared. Your outer is minus x times 1 minus 3i. Your inner is minus x times 1 plus 3i. And then your last is going to be plus 1 plus 3i, 1 minus 3i. Okay, and now we'll distribute because we made it a little bit easier. Distributing here would have made this a little tougher. This makes it a little easier. But you can do it either way. Okay, so that's going to give you x squared minus x, because negative x times 1, negative x times negative 3i, plus 3xi, negative x times 1 is negative x, negative x times 3i is minus 3xi, plus, now we go ahead and FOIL these, we have 1, your outer is negative 3i, your inner is positive 3i, and your last is negative 9i squared. Okay, so we're going to simplify this, but remember I squared is equal to negative 1. Okay, so we're going to simplify this, but first we're going to cancel out a few things. This cancels out with this one. We have positive 3xi, negative 3xi is 0. Negative 3i, positive 3i is 0. So we've simplified it a little bit. Okay, so we have x squared minus x plus 1 minus 9 times negative 1. Okay, so remember, negative 9i squared becomes negative 9 times negative 1, which is positive 9. All right, so combine those two. We end up with x squared minus, oh, forgot one there. We have minus x, that should be minus 2x. So minus 2x plus 10. Okay, so I'm just going to block that off because all we did was work out part of it. Okay, so that means going from here to here, f of x is equal to a times x minus something. Well, we'll say instead of something, we'll say some constant. We'll call C1. And we'll say x minus some constant we'll call C2. And these two, we simplify to this. So that's x squared minus 2x plus 10. Okay, so we're part of the way there. Okay, so how do we solve for these two? Well, to solve for these two, remember our f of x is equal to x to the 4th power. Let me scroll up a little bit. X to the 4th minus 3x to the 3rd plus 6x squared plus 2x minus 60. Okay, so this f of x is just x to the 4th minus 3x to the 3rd plus 6x squared plus 2x minus 60 is equal to, and for now we're going to leave the a out because we just want to see that x minus c sub 1, x minus c sub 2, and if we divide both sides by x squared minus 2x plus 10, it will cancel out on the right, and it would just be x squared minus 2x plus 10. Okay, now this is where we have to go back and use the good old-fashioned division of polynomials. All right, so we're running out of room on this page, so if you're still writing, feel free to press pause, but we're going to go ahead and move on to our next page. There we go. Okay, so we have x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60 divided by x squared minus 2x plus 10. Okay, that's where we left off on the previous page. So we're going to go ahead and rewrite it. Okay, so we have x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60 divided by x squared minus 2x plus 10. Okay, so remember your first step, get rid of this x to the fourth. So x to the fourth times what? Well, x squared times what will give you x to the fourth? Well, that's x squared. X squared times x squared is x to the fourth. X squared times negative 2x is negative 2x to the third. X squared times 10 is 10x squared. Okay, so we multiply, now we subtract. X to the fourth, remember this is being distributed. So x to the fourth minus x to the fourth is 0, so that disappears. Okay, so we have negative 3x to the third plus 2x to the third, because remember that becomes plus. So we get x to the third. We have 6x squared minus 10x squared. We have negative 4x squared. And now we bring down. Okay, so now we want to get rid of the x to the third. Okay, x squared times what will give us x to the third? That's it. Oh, negative x to the third, sorry about that. And that will be negative x. X squared times negative x is negative x to the third. Okay, negative x times negative 2x is positive 2x squared. Negative x times 10 is negative 10x. Okay, so we go ahead and subtract x to the third plus negative x to the third plus x to the third is 0, so that disappears. Negative 4x squared minus 2x squared, remember that's distributed, is negative 6x squared. 2x, well, positive 2x plus 10x is positive 12x. Okay, so we subtract it. Now we bring down the minus 60. Now we want to get rid of the 6x squared, or negative 6x squared. Okay, so what times x squared will give us negative 6x squared? Negative 6. So we multiply negative 6 times x squared, which is negative 6x squared. Negative 6 times negative 2x is positive 12x. Negative 6 times positive 10 is negative 60. So we're going to go ahead and subtract those. And negative 6x squared plus 6x squared is 0. 12x minus 12x is 0. Negative 60 plus 60 is 0. Okay, so we know that this is going to equal x squared minus x minus 6. Okay, so going back to the previous page, just where we left off. I'm just going to rewrite this part here. We know that x minus c sub 1 times x minus c sub 2 is equal to x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60 divided by x squared minus 2x plus 10. Okay, now we just saw that this is equal to this. So that means x squared minus x minus 6 is equal to x to the fourth minus 3x to the third plus 2x minus 60 all over x squared minus 2x plus 10. Okay, so if both of these are equal to this, then that means they are equal to each other. Okay, so starting off where we were before, it's x minus c1 times x minus c2 times x squared minus 2x plus 10. We just proved that x minus c1 and x minus c2 is equal to this. So that means our f of x is equal to x squared minus x minus 6 times x squared minus 2x plus 10. Okay, so we can go ahead and actually factor this out. This factors to x minus 3 times x plus 2. Okay, and we know this factors out, because I'm going to cover this up just for a second. This factors out to this, because this is how we FOILed it out. So we can go ahead and factor that back out. Okay, so that's x minus 1 plus 3i times x minus 1 minus 3i. Okay, and we didn't factor anything out of all of these, so that's why we know our a is equal to 1 here. So if you had maybe 2x minus 6, you could factor a 2 out of both of those, and your a would equal 2. But here, there's nothing to factor out of all of them, so we know your a is just equal to 1. All right, so your zeros are x minus 3 equals 0, x plus 2 equals 0, x minus 1 plus 3i equals 0, x minus 1 minus 3i equals 0. Okay, so that just means if you add 3 to both sides, you got x equals 3. Subtract 2 from both sides, you get x equals negative 2. Here, if you plug in x with, or if you add 1 minus 3i, 1 plus 3i to both sides, and if you add 1 minus 3i to both sides, these are your zeros. All right, so I know it was a little bit lengthy and a little bit complicated in some spaces, but if you're confused, I do recommend going back, retrying the example problems without looking at the answers, and see if you can get it on your own. And the minute you're able to solve them on your own without looking at the answers, then you understand the process. All right, so hopefully this made sense, and I will see you on the next video.